Assalamualaikum warahmatullahi wabarakatuh. So today, my group and I will present about the assessment that we get, which is the portal frame building that we have to choose. So our group chose St. Pancras International Station at London, United Kingdom. So here is our group poster that we had made together. So for my part, I will tell about the introduction and the building background. Okay, for the introduction, the goal of this study is to understand the type of the architectural construction and fundamental framework for the International Portal Frame Building, which is the St. Pancras International Station in London, United Kingdom. St. Pancras is one of the best known and the most influential groups of buildings in the railway period. It is not a typically railway structure, but it contains a feature of archetype by Victorian architect. The layout of portal frame in St. Pancras is usually low-rise structures consisting of columns and horizontal or pitched rafters linked by moment-resistant chains. This type of continuous frame construction is secure in its plane and offers a simple span that is bracing-free. Okay, for the building background, at the left side of this poster. Okay, for the building background, Saint Pancras Station was designed by the two engineers, which are W. H. Barlow and R. M. Ordish, and it has opened in 1898 as the terminus of the Milan Railway. It consists of an arch which more than 30 meters high and spans a 70-meter track. The concourse and facade of the station was aided towards completion in 1966 and was designed by the George Gilbert Scott. St. Pancras is preserved and is a document of national history. Also, is considered as an expression of the power and pride in cultural and national achievement. It remains the largest single-span enclosed space in the world. So the building was deterring through the neglect, and the British Rail spent approximate 9 million pounds sterling for maintenance purpose consists of cleaning brickwork and repairing damaged area. For the rebuilding costs took up to 800 million pounds from the initial estimate 310 million pounds sterling. The main material that are used for this building were an iron framework of the latest design with glass covering the middle half and the timber for inside and slate for outside to cover the outer quarters. So that's all from me. Thank you.
Assalamualaikum, I am Aiman Nasir and I will explain about the structure of the St. Pancras station. As we can see here, the station are designed with the single span roof trusses to avoid the foundation of the roof to interfere the space beneath it, and also to simplify the design and to find a way to save the cost. The lattice girder, or referred as the curved trusses beam, act as the framework for the material of the roof beam. The roof are designed with a height of 240 feet and are covered largely with clear glass to provide the structure with natural light. So next, the roof are designed with a curved steel roof to provide the sense of spaciousness, and the girders here is to tie that the roof arc are loaded free. The undercroft space here is the space below the train deck used for the arrivals and departure lounges, and also for the retail facilities such as convenience store and also restaurants. That's all from me, thank you.
Okay, move on to the next part, which are compression and tensions. So basically, compression is a force within a structural system that squeezes down across or even up on another structure member or immobile components, while tension is a state of stress in which a material is being pulled apart. So let's say if you take a steel section, let's say a steel bar, then we apply force in this direction, right and left. Then this steel section goes into tension. Okay, I can give you an example like a rubber band. Raven, if you try to pull it apart, it try to push your fingers together like this. So same thing happens here. This steel section tries to work against his force. So basically, This section is intention. And now, if we take a concrete column and we with a support at the bottom and we apply a force at the top, then we will have a reaction. And this section goes into compression because the sections try to work against the force we are applying in this direction. So basically, this concrete column is in compression. So concrete is an excellent structural member under a compressive force due to its physical characteristic. And steel is good in tension. That is why we use a rebar in a reinforced concrete. So, as you can see here, this simply supported beam will support on both ends. So, let's say there are something pressed down the curved structure, it doesn't move as much because the force of compression is pushed downward along the curved lattice beam toward a joint to column itself. So, column will transmit the compressive load from superstructure to substructure. Okay.
Next, I will explain about the failure in the column. Column can fail due to the buckling, which is a sudden or large lateral deflection before the compressive stress in the column reach its allowable value. Buckling can cause the catastrophic failure of structure. With increasing compressive loading, the column becomes unstable, which is called critical buckling load here under the unstable equilibrium condition. If there is non-circular cross-section, the column will buckle about the smallest moments of inertia. The vertical or horizontal loads will be carried to foundation and soil, which is the substructure. If it is overloaded or the substructure, the compression will squeeze or push away the trusses beam while tension is increasing with stress, or pull away the trusses widely. It will deflect and cause the bend to the beam. The dead load is the roof load and the structure or fixed component supported by beam. The force is gravitational. It imposes loads on roof depends on the roof slope and also known as permanent forces.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Rushida binti Rosli and my metric number is 2019266. And for today, I will be presenting about bending, shear, and torsion. So based on the poster, beam is curved to resist the torsion. If the end of the beam connections are not stiff enough, the beam will free to twist, which is easy to be said. It will cause torsion. The higher the distance of single beams, the higher the bending moment. The bending action causes the top of the beam to be in compression and the bottom is under tension. The truss on the roof structure is able to deal with design load by transferring the load through tension and compression to the cast iron column. If the tension load placed on, it may cause failure because truss cannot deal with the additional forces.
Thank you, Shida, for the explanation on the bending, shear, and torsion of the structure. I am Ami Haris Khan, and I will be adding a little bit more information on bending, shear, and torsion. So the bending moment on the structure is positive, and for the shear, wind loads on the curved beam are asymmetrical when the wind blows along the single span of roof. Shear attempts to make the building materials slide past one another, but shear does not affect deflection of the beam. Maximum vertical shear occurs near the supported beam. And for torsion, the compression and bending moment in the curved structure must increase to resist the vertical load, which it might overstress the curved beam. And that is all from me. Thank you.
Okay, now I'm going to present about the stiffness on beam. Stiffness is important to limit the effects of deformed geometry. The compression and bending moment in the curve must increase to resist the vertical load such as dead load, wind load, which it might overstress the curved beam. The increasing bending of the curved beam will cause an increasing spread of the abutments, then cause the beam collapse entirely. So it means that if there is bending happen, there are shear and torsion also occur at the same time. So to avoid the over shear or the high forces of shear and torsion, the reinforcement steel is added to this beam. As you know, the truss reinforced composite, the steel concrete beams are usually adapted to cover the large spans beam, which also apply in this station. So the material used for this beam is reinforcement steel concrete beams, which it will resist the both compression and tension forces. And as you know, why then they choose the reinforcement steel instead of just concrete beam? It is because the concrete beam has low tension strength, and the concrete can resist the compression but will break under the tension. So that is why the reinforcement steel is added. So steel has good tension strength, and it can bend without breaking it. So when the bending happens, the shape will go back to normal after the load is removed. So I think it is important to have the good stiffness and for the long-term use. Okay, so I think that's all from our group. Thank you.